Hello viewers, in today's lesson we are going to discuss what we mean by relation and also introduce you to the understanding and the terms domain and range of a relation. Let us start with an example. There is a set A which lists out 4 names and set B where we have 3 flowers: rose, sunflower and carnation. Now, I know the personal preferences of these 4 people in terms of what they like out of these 3 flowers. We know that Aparna likes carnation, Vasudha likes rose and carnation, Ramit likes sunflower, whereas Kritika likes rose and sunflower and carnation. So, we are looking at some kind of an association between the set A and set B. Now, instead of using this representation which is used and referred to as the arrow diagram, I can list this association as an ordered pair. So, Aparna is now paired with carnation, Vasudha with rose and carnation. So, I have 2 ordered pairs, Vasudha and rose, Vasudha and carnation, and similarly other ordered pairs. These ordered pairs can always be put in one set, and this set is referred to as a binary relation from set A to set B. If I take an element of this set, say Vasudha comma rose, then I say that Vasudha comma rose belongs to R. Same as saying that Vasudha is R related to rose. In plain simple English, it means that Vasudha likes rose. And so, if I am looking at the possible collection of all these 4 elements with these 3 in the set B written as an ordered pair, it is actually nothing but A cross B, the Cartesian product of the 2 sets. So, I have 4 elements in set A, 3 in set B, leading to A cross B with 12 elements represented as Aparna comma R, where R now represents rose. And therefore, what was this set R? This set R that we talked about as a relation is nothing but a subset of A cross B. Now, if R is a subset of A cross B, then it is also interesting to note that A cross B had 12 elements and R is one of such subsets. Now, there is always a possibility that all these 4 people, that is Aparna, Vasudha, Ramit and Kritika, may like all these 3 flowers, and therefore, I will have 12 elements in the set R. That means, the relation can be A cross B itself also. At the same time, 4 of them may not like any of these flowers. So, R, that is the relation, could be an empty set, and therefore, we are looking at a relation to be defined as a relation R from a non-empty set A to a non-empty set B to be the subset of the Cartesian product A cross B, where R could be the entire A cross B, R could be any of the other subsets of A cross B, and R could also be the empty set. And so, in other form we can say R is a relation from A to B if and only if R is a subset of A cross B, can be equal to A cross B, may be an empty set as well. So, it is not a proper subset of A cross B. This also leads us to the definition of what we mean by domain of a relation. The definition states that domain is the set of all first elements of the ordered pairs in a relation R from a set A to set B. What in the context of previous example it means is the set A consisting of all the 4 names of the persons that we were referring to. That would become the domain of the relation. And what would become the range? We defined range to be the collection of all second elements in a relation R from a set A to set B. Also, the term codomain is a term related to the idea and the concept of relation. So, the entire set B from where the elements can be related to the elements of set A is referred to as the codomain. We also say that range is the collection of all the images of the first element that are present in the ordered pair that is part of the relation. So, the second element in that ordered pair is referred to as the image of the first element, and range is the collection of all the images. So, keep these two definitions in mind and we will be referring and using these again and again. Also note that range and codomain are not always equal, but range is always a subset of codomain. So, in the previous example, domain of the relation R will become nothing but Aparna, Vasudha, Ramit, Kritika all enclosed in a set. Range of R in this case would consist of these flowers that we referred to and is also same as the codomain of the relation R. So, again as in your previous example you saw the two sets related through arrow diagram. Here also the relation is represented with arrows, and if you see it closely it just says that 1 is related to 5, 2 is related to 7, 3 to 9, 4 to 11 and 5 to 13. So, the roster form for this relation will nothing be but collection of ordered pairs listed as 1, 5, 2, 7, 3, 9, 4, 11 and 5, 13. So, now when you are asked to convert this to the set builder form, what you have to do is express this relationship in words. How is the second element in each of these ordered pairs related to the first element? So, if you try and see what should I do to 2 to get 5 and the same trick to 3 to get 9 and same to 4 to get 11 etc. Nothing but multiply the first element with 2, add 3. Do I get the second element for each of these ordered pairs? Surely, and that is how you write the set builder form. Collection of all ordered pairs x, y such that y is 2x plus 3, x is coming from the set P and y belongs to set Q. Therefore, the domain of R is all elements present in the first position in the ordered pairs. So, that means 1, 2, 3, 4 and 5. How about the range? We said range is collection of the images. So, each element of the set P had a image in the set Q, and those images when put together as a set result in range, in this case 5, 7, 9, 11 and 13. And now maybe you can also ask what would be the codomain of this relation R. So, you can see that the set Q also had 15, which is not connected with any element of the set P. So, if I take the entire of the set Q, that would become nothing but the codomain of the relation R, and in that case range is not equal to codomain, but range is a subset of codomain. Here is another example. Let A be the collection of elements x, y, z, B has 1, 2. Can we find the number of relations from A to B? Now, the number of relations from A to B can be decided if you remember that R is a relation from A to B if and only if R is a subset of A cross B. So, how many elements do we first have in A cross B? 3 times 2, 3 elements of A multiplied with number of elements in set B. And therefore, how many subsets can be formed of A cross B depends on this number and of course, that little result that you picked up somewhere in the previous chapter. And therefore, the number of relations from set A to set B, same as the number of subsets of A cross B, will be 2 to the power 6, which is same as 64. So, 64 relations can be formed from set A to set B, and that is a little result that is at times tested as a 1 mark question as well in your exams. Here we have another problem for you. Set A is 1, 2, 3, set B has 4, 7, 9. Which of the following are relations from A to B? Also justify your answer. So, if you see here, I have this part 1 which has 1, 4, 2, 7, 9, 3 in a set. Is this a relation? For this set to be a relation, you must make sure that it is a subset of A cross B. At the same time, each element of this relation must be an element of A cross B as well. So, if you see closely, 9, 3 does not belong to A cross B, because 9 comes from set B. So, 9, 3 actually belongs to B cross A, and therefore, R in our first part is not a relation. Second, yes, is this a relation? 1, 7, 2, 9, 2, 7, 2, 4. All of these elements are coming from A cross B. So, R is very much a subset of A cross B and hence relation. A cross B being subset of itself is a relation from A to B. Again, our last example there, R which is 4, 1, 7, 2, 9, 3 is not a relation from A to B, as R is not again a subset of A cross B. So, definition is just what is more important, and to identify whether a given collection is a relation or not, you need it. Here is another problem, domain and range. You have to find domain and range of the relation R, where R is defined as x comma x cube, such that x is a prime number less than 10. So, we are looking at all such collections which are formed taking the condition that the second element is the cube of the first, but what is the first element coming from? A prime number less than 10. So, 2, 3, 5 and 7 are the 3 prime numbers less than 10, and therefore, the ordered pairs that satisfy this condition would be 2, 8, 3, 27, 5, 125 and 7, 343. So, that is how you express this relation. What is the domain of this relation? Definitely all the 4 prime numbers less than 10, and the range, the list of all the elements that are present in the second position. So, the set consisting of them is 8, 27, 125, 343, and that collection is called the range. Here is another example. Let A be equal to 1, 2, 3, 4 and 5. R be a relation on A defined as an element x comma y belongs to R if and only if x is less than equal to y. Express R in roster form. So, this is another way of stating the relation. X is related to y if x is less than equal to y. So, again when I say a relation from set A to A, it is also in short read as a relation on A. So, R in this case is going to be a subset of A cross A, and therefore, R would turn out to be collection of all ordered pairs such that x is less than equal to y, and you can sit and just list them down, making sure you do not miss any one of them, including 5, 5, 2, 2, because x is less than or equal to y, and that is what our last exercise is. I hope with these problems the concept of relations is now clear to all of you. In our next lesson, we will be talking about a special condition which makes a relation a function. See you.